Okay, students, now we will understand some more numericals based on Newton's 3 laws of motions. So this question is based on action-reaction forces, that means Newton's third law. What is the question? A wooden block of mass 2 kg. Okay, it rests on soft horizontal floor. Soft horizontal floor means the floor which can be depressed also by the weight of the object. Okay, so this is the soft floor. Now an iron cylinder of mass 25 kg is placed on the top of the block. So this is the block. On this block, in the second case, one iron cylinder which is very heavy, 25 kg, that is kept. So what happens? The floor yields steadily. Floor yields means the floor leaves its position. So if this is the soft floor, it will be depressed down a little. Okay. And what is the acceleration? The block and cylinder together go down with the acceleration of 0.1 meter per second square. So this floor which was at this position, now it is depressing down and acceleration is given. That means this whole system which is kept on this floor, that is also moving down with the same acceleration. Okay. Now what is the question? What is the action of the block on the floor? What is the action, okay, of the block on the floor before and after the floor yields? Okay, before and after case. So you can see that the diagrams have been made. Before case is this, after case is this. Okay, now let us solve this case first. We have to solve that what is the action by the block on the floor. What is the action force? Okay, now action force is actually equal to reaction. So let us solve the reaction. Okay, so you see now, we already know that weight mg is directly action here. Weight mg of this block on the floor, that is action, and reaction is r equal to mg only. So here directly we can solve that the action of the block on the floor is mg. So here the action force answer is mg. mg means 2 into g, that means 20 Newton. That's it. Okay. So mg means 2g. 2g is g is 10 taken, 20 Newton. Now here let us understand the situation. In this case also we will be solving the reaction force first, and with that help of reaction force we will solve action force. So actually we have to only solve reaction force. Okay, now how to solve reaction force? First of all, now the total weight of the system, total mass of the system is 27. 25 plus 2 is 27. So the total weight 27g will be downward acting by the system on the floor. Okay, then one more thing, if this is downward action, so reaction force normal to the system will be, suppose, r dash. Okay, upward direction normal reaction will be r dash. Okay, what other force is here? You can see acceleration is also present. So acceleration also gives rise to the force. So on what force? On this total system, that means block and cylinder system. This block and cylinder system is also moving down because this floor has been moved down. So by what acceleration the floor is moving down? By same acceleration this system will also move down. So one force MA is acting downward. Okay, one force MA is acting downward. So these are the overall forces, okay, on this total system, block and cylinder. So on this block and cylinder, weight mg 27g is downward, normal reaction r dash is upward, and MA is downward. Now let us make firstly the equation of all these three forces. How to make? MA is resultant. Okay, MA को हम resultant बोलते हैं. MA resultant of what? Of these two forces which are opposite. Opposite forces are always subtracted. So 27g minus r dash. This is the equation prepared. 27g and r dash are opposite, so they are subtracted. Subtraction is always done from bigger one. Okay, so because the direction is downward, so 27g is bigger one. Okay, now r dash reaction is our need. because by solving reaction only we can get action force. So reaction is needed here. So what is the reaction's answer? R dash is shifted here, it is becoming plus, and MA is shifted there, becoming minus. So 27G means 270 minus MA. Now this MA is total system is moving down with some acceleration. So total system means 27 kg is mass and acceleration is 0.1 given in the question. So overall we need to solve this to get our reaction force. So finally the answer of reaction is 267.3 Newton after subtracting. So whatever is the reaction to the system, to this whole system of block and cylinder, same is the action force. So by solving reaction we got action answer. Okay, this way we have solved the two cases. Let us move to the next question. Note down this question. Okay, now this question is related to the lift cases. That is very important question. How do we solve the weight in the weight or weighing machine reading in the lift? Question is a man of mass 70 kg. Mass of the person is 70 kg. He stands on a weighing scale in a lift. Okay, lift case is there, which is moving upward with uniform velocity, this case, downward with uniform acceleration, upward with uniform acceleration, and lastly freely falling. Okay, now just understand this case we have understood in the gravitation chapter also. What is the idea? First of all, this person of mass m, if he is standing on the weighing machine, so weighing machine has a spring. By whatever force we depress the weighing machine, that means action force, that weighing machine gives the reading equal to the reaction. So actually the weight which we or the reading in the weighing machine is actually equal to reaction. Remember this point. The reading of the weighing machine is equal to the reaction given by its spring to the person. Okay, that way it is. So let us show here all the forces. This lift is a surface. So since this person is touching the surface, so weight mg is downward and the floor of the lift gives the reaction force in the upward direction. So here reaction is equal to mg. Why? Because in this case the lift is moving, but lift is moving with uniform velocity. That means no acceleration. If no acceleration, that means no extra force is there in this case. So R is simply equal to mg. So here the reading of the weighing machine is what? M means 70, G means 10. So we will write it, its answer 700 Newton. Now come to this case. These two cases are interesting where acceleration of the lift is there. Okay. We have to find all the forces working on this man. So weight mg is downward. Then the floor of the lift or the weighing machine, that gives equal reaction force to this object. And since this lift is moving downward, so MA force is also acting on this man downward. So on this man there are three forces: weight mg downward, reaction by the floor upward, and MA force downward. Now here our target is to find this R, which is the reading of the weighing scale. How to get the reading? So we will make the equation of MA. MA is downward, which is the resultant of these two. R and mg are opposite, so we will subtract them. But from which force? We have to subtract from mg, R force. Because MA direction is downward, that means mg is bigger. So mg minus R is equal to MA, but our target is to find this R. So R will be equal to what? Mg here only, MA shifted here. So you can see here, why do we feel lighter when we are in the downward moving lift? So when the lift is moving downward, with any acceleration, then the person feels lighter in weight, because that reaction which it is getting from the floor of the lift, that is what we feel. So that is felt is mg minus ma. Actual weight of the person is mg, but he is feeling only mg minus ma weight. Okay, so this is the apparent weight, or you can say it is the reading of the weighing scale. So if we apply the values now, mg is 70 into 70 is the mass, g is 10, and here 70 into acceleration. Acceleration here is given in B case 5. So we will apply it. So final answer is 70 into 5, 350 Newton. Okay. Now let us come to the C case in which the lift is moving upwards. Okay. Now what is the change? Only MA direction is upward, MG was down, R was up. We have to make the equation connecting these three forces. So MA equal to now R minus MG. I think you have understood how it is. R and MG are opposite, so we will subtract them. And since the MA direction is upward, that means this is resultant. So its direction is upward, that means R is greater than MG. So R minus MG we need to do. Here we did MG minus R. Here we need to do R minus MG. Now our target is to solve this R. So R is MA plus MG by shifting MG here. Okay. After that now this is like MA plus G. And you can see one more thing. When any lift is moving upward and in that lift we are present, we are standing, so we feel heavier because our actual weight is mg, but how much we are feeling, how much we are experiencing, that is R. It is equal to mg plus ma. So we are experiencing more than our actual weight. That's why we feel heavier when the lift is moving upwards. Okay. Now let us put the values here. M is 70, A is 5 now also, G is 10. So 70 into 15, we will solve this answer. 15 15 7 size, okay, 1050 Newton is the answer of this reaction or reading of the weighing scale. Okay, this way we solve. Now what is the last case about? In the last case, what should be the reading if the lift mechanism has failed? That means the mechanism which is controlling the lift's motion, that has been failed. So lift automatically will come down, okay, under the earth's gravitational force. So its acceleration is downward but equal to g, because it is in free fall condition. So it is this downward case only, but this A equal to now g. So the equation of R will remain same only, R equal to mg minus ma. So we will write it mg minus ma written, and let us put A value equal to g. Acceleration of the lift is also g now. So mg minus mg, final answer is coming 0. That means when any lift is freely falling, then the person inside it is feeling weightlessness. Okay, weightlessness condition. Because you can see what weight he is feeling. He is not feeling any weight. Okay, so he is under the condition of weightlessness. You should remember the direct answers. If the lift is moving downward with some acceleration, then the R formula is mg minus ma. Okay, and if it is moving upward, then the formula is mg plus ma. Okay, you can remember it this way. If it is moving downward, arrow down, that means its final weight should decrease. This is the decrease sign. That way also you can remember it. So mg minus ma. This is increase sign. So mg plus ma. Okay, this is just a learning technique. Okay, note down this question. Okay, now this is a coin question and action reaction forces. Okay, let us see. 10 1 rupee coins, each of mass m, are put on the top of each other on a table. Find few things. Okay, first thing is the force on 7th coin. Counting we are doing from bottom. Okay, In the question it is written counted from bottom due to all the coins on its top. Okay, let us just make a stack of the coins. This is coin number 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, these are all the coins arranged. Now what is the question? We have to solve the force on 7th coin due to all the coins on its top. So just look at the 7th coin. On the 7th coin, how many coins are present? 8th, 9th and 10th. 3 coins are present and each coin will apply the force downward only. Which force? mg. So that means we can say it this way. A part is this. On this 7th coin, there are 3 coins, 8th, 9th and 10th. Each weight is mg. So total is 3 mg. So that means 3 mg is the answer. And what is the direction of this 3 mg? Downwards. It's an easy question. On the 7th coin, what is the total force by all the coins on its top? So because only 3 coins are present on its top, so total weight will be 3 mg or total force will be 3 mg. Okay, now B part. What is the force on 7th coin by 8th coin? Okay, force on 7th coin again by 8th coin. Okay, but is the 8th coin alone? No, on the 8th coin, 9th and 10th are also present. So the situation is similar. 8th, 9th and 10th. What weight this 8th coin will bear? So 8th coin will bear its own weight and the weight of upper 2. So again the answer is same. How much weight the 8th coin will apply on 7th coin? That is 3 mg again. Okay. If the case is like that 9th and 10th are removed, then we can say that only the weight of 8th coin will work on 7th coin. So what is the question? Force on 7th coin by 8th coin. And all the coins are still present. That means we have to count all that coins which are present on 8th also. Okay, so the answer of B case is also 3 mg and its direction is also downwards. Now let us solve the C case. What is the reaction force of 6th on 7th? Okay, let us understand it with the help of action force. Just understand this meaning. You have to just interchange the names. If reaction of 6th on 7th is asked, reaction of 6th on 7th, that means it is action of 7th on 6th. Correct? Okay, now let us make this picture. If we see this diagram, action of 7th on 6th. So focus on 6th coin now. This is the 6th coin. So action of 7th. So 7th coin is applying how much force on 6th coin? So 7th means 7th, 8th, 9th, 10th. All are above. That means the 4 coins are above it. That means 4 mg weight will be applicable on 6th coin. Right? Okay, we can make the diagram like this. 10th, 9th, 8th, 7th and this is 6th. So total action by 7th coin on the 6th coin is 4 mg and whatever action 7th applies on 6th, that same reaction 6th applies on 7th. That's why to solve the reaction force here, we will be taking the help of action forces. So just interchange the names. Okay, so reaction of 6th on 7th means action of 7th on 6th. Okay,